We're going to walk through the steps on how to use MATLAB and Simulink with the temperature control app. We have two sensors, two temperature sensors, and two heaters, along with an LED just to indicate when it's hot. We put these two together into two zones, and so that one heater was going to affect most drastically the temperature of one, and then the other heater will affect the temperature of the other, but they'll also affect each other. They're close enough in proximity. Then we'll have, again, this LED. There's a lot of things we can do with this lab. We can do open or closed loop. In this case, we're just going to test the open loop capabilities with MATLAB, do a step response. We can do single input, single output, multiple input, multiple output, on-off control, PID, feed forward, model predictive control, and then also a number of identification and estimation activities. So let's go ahead and just open up some of the files and start working with those. So come to an internet browser, and what you can do is just go to APMonitor.com/heat.htm. And that'll redirect you to another address here, which is the longer version of that lab address. And just come down here to download Arduino lab files from Github. So these are the files. We're going to use this first folder, 0 test device. And what you can do is come to the clone or download. There's your Git URL. Or you can come here to the download zip. I'm just going to use download zip, and then I'll do save as, and I'll just put it on my desktop. This is going to be a zip file. The very first thing you're going to want to do is, after you have that, is go ahead and unzip it. I'm just going to right click it and select extract all, and I'll extract it to my desktop as well. Within that folder, we're going to have 0 test device. And then I'm going to go ahead and open up the MATLAB folder. And the first one I'll do is go ahead and test LED. This is just going to test whether the LED is going to turn on. And this tests just the basic functionality of the device. What I'm going to do here as well is go ahead and bring up just a camera of this. Okay, there I have it. Zoom in just a little bit more. And let's go ahead and put this off to the side. And I'll put this off over here, make this a little bit smaller, just so we can see both of them. Okay, what it's going to do is it's going to load, first of all, TC Lab, and then it'll have the LED on and off repeatedly over the course of 5 seconds. And then we'll also change the brightness from 1 to 0 in increments of 0.1 going down. Then we'll print out that the LED test is complete. If you run it the first time, you may need to put something in there about, the COM port or something like that, if it's the very first time you've used it, and it gives some instructions there in the script if you run into that. Okay, so it's going to go ahead and make it dimmer. You'll go ahead and see it dim out gradually, and then it will turn off. It says LED test complete. So the main function that we're using here is just this LED right here. We can go ahead and turn on the LED now after loading that. We can do LED 1, and that turns it on. LED 0 turns it off. And LED 0.1 just makes it really dim. Okay, so there's the LED function. It's the very first one that I wanted to show you. Now let's go ahead and just do the test read temp. And if you run that, then it's going to read the temperatures. It's going to turn on the heaters for 30 seconds and then go ahead and turn them off. So it'll read the temperatures initially and then run for 30 seconds and then turn them off. Okay, right now it's a chilly 15 degrees, and we'll run this for 30 seconds and then turn it off, and it'll read the temperatures again after setting the heater 1 to 30% and the heater 2 to 60% for 30 seconds. So after the 30 seconds, it'll say temperature test complete. Heated them up just a little bit, and you can see temperature 2 is just a little bit hotter than temperature 1. Okay, the main thing that we have here is heater 1. I can say that heater 1 equals 100% for example, I just turned on heater 1 to 100%. Heater 2, I could say that's maybe 20%. And then I could say TC1, okay, and I could read that. Oops, let's see, T1C. See the functions over here that you can access. T1C, and then there's my temperature. And if I do T2C, then I can see that temperature. These are in degrees Celsius. Okay, so that's the basics. Don't forget to turn off your heaters, or you can always unplug it when you're done as well. Okay, so my heaters are off. And let's go ahead and go to the next one. I'm just going to run through some of these scripts just to show you the basics of how to control this device. And then we have the next one is test heaters. So this is going to be our step response. And we'll go ahead and run it, and then let's go ahead and see the plot that it opens up. Okay, now this is going to be the plot. It's going to show the temperatures, and I'm going to go ahead and close out this. It'll actually show the LED brightness will correspond to the temperature, so as it heats up, that LED is going to get brighter. Okay, but I'll go ahead and close that. It's already at a fairly high temperature. You can blow on it, for example, and make the temperature change. I'll go ahead and do that. Okay, it's me against the heater, I guess. But I did make temperature 1 drop just a little bit there. And then what we'll do is we'll let this go for a little bit more. We have heater 1 on right now, but heater 2 is off. And so that's just going to run through. It's basically just collecting a temperature every second as it goes through, and you're going to go and see the heater 1 temperature rise. It's going to go for a period of time, and then it'll turn off heater 1 and then turn on heater 2. So this would be like a step response. Maybe if you wanted a step response model, you'd run this and collect the data and then generate the step response. And that could be used to come up with, for example, initial PID tuning parameters or identify a model of the process. Okay, so that's the second one. I'll go ahead and just wait till it turns off that heater just to show somewhat of the separation between the temperature 1 and temperature 2. Okay, it said turn off heater 1. Okay, heater 1 is now off, and then it's going to wait a period of time and then turn on heater 2. So heater 1 and heater 2 can go between 0 and 100%. Okay, and I'll go ahead and just do Control C at the command line. Just go ahead and stop that. What I want to show you now is, let's go to the Simulink and show you some of the functions in Simulink. This is just the Arduino lab, and there's a couple other functions that are in there as well. One of the things I've done with Simulink is just showed a couple blocks that have a linear model, a nonlinear model, and then the device itself, and then we can compare those. So here is a linear model up top here, and that just has a first order plus dead time. Okay, you can edit that by double clicking there. There's the delay, so just FOPDT model, and there's the nominal maybe room temperature. You can change that. Here's the nonlinear model, and that executes every second to essentially produce a prediction. It's in Arduino Sim. So if we open up Arduino Sim, we'll just see the simulated model, and this just uses ODE15S to simulate one time step forward and then returns it. It puts a little bit of noise in there as well. You can remove that if you like. And then if we come back here, we also have our Arduino ODE. Now this is the ordinary differential equation that describes the temperature response. And there's my differential equation that comes from a heat balance. Now I didn't include things like conduction or radiation, and so there's you could make this a little bit more sophisticated and maybe get a better prediction. Okay, so there it is. I will go ahead and run this now. I've got these models. Oh, and the final one I wanted to show you is just this one. This is the Arduino, and this is Arduino Lab 1. Switch that to Arduino Lab 2 if you want to get the second temperature sensors. That's basically just the heater coming in, and that's heater 1, and that's temperature sensor 1. Okay, so I'll run this. Now it's already a little bit preheated from my last test, but let's just go ahead and watch the temperatures. And I'll go ahead and open up this heater plot, or the temperature plot here on the right. Now I have this real-time pacer. Just leave that at 1 because it's going to need to remain real time. So we want to keep our models synchronized together, and so you can see our the heater turned on. I gave it a step input, and there you can see the yellow is the linear model, the blue is the nonlinear model, and now again I had added some noise to that, and then the red is going to be the actual temperature control lab, the actual data that is there. Now you can see that the three are kind of tracking together. We'll see if we can refine later on with other activities that we'll do with this lab. See if we can refine the models to agree with the measured values. Okay, so we have just kind of a first model, a couple models there, a linear model and a nonlinear model, and it looks like the actual values are a little bit closer to the linear model right now. And right now it just got about 40 degrees, so the LED light turned on. I had that programmed in there, but you could set that trigger at whatever level you'd like. Okay, so it's going to continue with this step response. You can see this is real time. If you need to adjust the plot axes, you can with this. It'll kind of automatically rescale it for you. Okay, and you can rescale the X and the Y values here. And okay, so there it is right here. It's going to be going up to 500 seconds in this case. You could set that to something else if you wanted something shorter or faster. Okay, so there's our Simulink and our MATLAB. Now this is just how to use the different functions. Now, if you wanted to do temperature 2, you just copy this one and change that out to Arduino Lab 2 instead inside this model. Okay, so you just change the name of this to Arduino Lab 2. Okay, so this is how to generate a step response. It's kind of a this one's very flexible. You can use the lab in many different ways, and but these are just kind of the starting points for the lab.